Well, hello there. We're going to crank out a brand new unit on polynomials, and we're going to start by talking about what they are and how you can tell by looking at them kind of how crazy they can get, and we're going to name them. We're just going to start with the very basics. We're just going to name polynomials, and I think in doing so, we're going to cover or recover some stuff that you might have learned previously, but hopefully you can see it in a different light. So I want to be able to help you out with some stuff. So I have a list of 9 different polynomials. So you can't see all of them yet, but you will. And all we're going to do is find the degree and name them. So we're just going to say, hey, that's this type of polynomial, and hey, that's that type of polynomial. So we're going to keep it really basic. But before we do, like I said, I got to cover some background information. So we're going to have to know what the vocabulary is for both a degree and name. Believe it or not, it's more complicated than some people might think, or in some cases a lot easier. Anyway, let's start with the word degree. What is the degree of any polynomial? The degree of any polynomial is real basic. It's the highest exponent of that polynomial, and that is it. All right. So there is nothing more complicated. Nothing more complicated than that. So you can have something like a first degree or a 10th degree or whatever, because it all depends on whatever the highest exponent of that polynomial is. That's the degree of that polynomial. So degree, pretty straightforward, right? So that's the easy part. Find the degree of each polynomial. The name of a polynomial, however, that's where stuff gets pretty tricky. So when we're talking about the vocabulary for the name of a polynomial, the name of the polynomial depends on the number of terms in that polynomial. So it all depends on the number of terms. But before we can talk about the number of terms that are in a polynomial, wouldn't it be helpful to know what a term is? So now we have to talk about, well, what's a term? So I don't know what a textbook definition of a term is. I have my own definition, and I like it better. So we're going to use that one. So what is a term? In my definition, a term is simply a piece of math. Right? That's what a term is. It's a piece of math. And well, now we got to look into, well, what does a piece mean? Right? So now this is where stuff gets a little bit crazy. So what does piece mean? So a piece means that it's something that's separated by a plus or minus. All right? So something that's separated by plus or minus. That's what a piece is. Okay? So a term is a piece of math, and a piece means it's separated by a plus or minus. Now the term has something else. Okay? So it's not just it that's a piece of math. The term has something else to it. The term also has a unit of measurement. Okay, so term has a unit of measurement. And so this is where stuff gets interesting, background information. So what is a unit of measurement? Now we talk about unit of measurement, and unit of measurements are things that we are hopefully familiar with anyway. So units of measurement are things that we know, like miles and kilometers and seconds and hours and days. And so they're things that we measure in historically either distance or time. So things like inches or seconds, right? Those are units of measurement, things that we measure in either distance or time, right? And we're used to that. We've done that our whole math lives, right? So that's a unit of measurement. But there's other things that we can also measure. Like if we're in a classroom and we can measure, how many boys, how many girls, or how many people with green eyes, how many people with blue eyes, how many people with, brown eyes. And so we can also measure things in categories. Okay, so we can measure things like, apples and bananas and fruit and boys and girls and desks and cars and all that stuff. And we have units of measurement that can also be categories. And we can also do units of measurement by way of dimensions. And this is where things get pretty crazy. Okay, so we can also measure things by dimensions. Now, what does that mean? Well, what is a dimension? So take something like this. If we have, a certain length of something, right? We have a length of things, and how would we measure the dimensions of a length, right? We would take a measuring tape or a ruler or a stopwatch, whatever, mostly a ruler or measuring tape, and we would measure it in units, okay? Plain old units, centimeters, inches, miles, whatever it might be. Good old units, okay? Maybe something U. Okay, so we maybe use the variable U or X or A. It doesn't matter what the variable is, just that's what that is. All right? So we have length measured in units. Now, we have something else called area, right? So we have area. And how do we measure area? Hopefully some stuff is coming back to you right now. Well, how do we measure area? Measure area in square units. Right? So hopefully that's something that you should know. This is information that everyone needs to know. Length is measured in units, area is measured in square units. That's a thing that everyone needs to know. And then we would say, something in square units, let's say we'd use the variable u, and it would be to the second power. Don't need to know that so much as you need to know this. This is basic human information. We should know that stuff. And so we have dimensions. We have one dimension, which is length. We're just measuring a length. We have two dimensions, which is area, or square units. And then we also have three dimensions, and that would be called volume, right? And so we have length, we have area, and we have volume. And how do we measure volume? Well, hopefully we measure volume in cubic units, right? So we have cubic units. Or, a lot of people watch TV and they see these drama shows and hospital shows, and someone needs like 30 cc's of whatever stat. Well, what is a cc? Cc is cubic centimeter, right? So volume, like an amount of liquid or amount of stuff. It's like this amount of stuff. That's volume. We measure volume in cubic units, and so we would call that u to the third power. And these are dimensions, okay? So we have dimensions, length, and area, and volume. And so those are also units of measurement. And here's what I'm talking about, right? So how can we add things of different units of measurement? We really can't, right? Unless you can convert one thing to another. Right? How do I add 5 apples and 4 bananas? You can't have 9 apple bananas or banana apples. You just have 5 apples and 4 bananas. It's just how it works. But if you have 4 inches and 5 centimeters, can you convert one to the other? Then yes, right? So then we can do that. But if the two categories are different, we can't really add them. If the distance or time is convertible, we can add that. And then we have dimensions. Can we add a length to a volume, for example? Can I add 5 centimeters plus 4 cubic centimeters? That doesn't make any sense. So no, we can't add them. And hopefully this starts bringing back memories when you hear things like, like terms. So you remember what like terms are. Like terms are terms that have the same units of measurement. Okay, so when we talk about like terms, that simply means we're dealing with the same units of measurement. So what does that have to do with polynomials? Well, remember, we're naming polynomials, right? So if we're naming polynomials, we have to keep in mind that the name of the polynomial depends on the number of terms. And what is a term? A term is a piece of math separated by a plus or minus sign with its own unit of measurement, either distance or time or categories or dimensions, like u squared, u to the third power. And the dimensions is what opens up a whole can of worms, okay? Because if you can have u and u squared and u to the third, why not u to the fourth power? Is there a fourth dimension? Some would argue yes. Is there a 10th dimension? Some would argue yes. Is there a dimension where you have 2 different dimensions being multiplied together? Some would argue yes. So we get into crazy stuff, but that's where the naming comes in. So aside from the number of terms now, we also have prefixes, okay? So we can work with prefixes for what we're naming. And the prefixes all depend on Latin stuff. Okay, so for example, if we have one term, we would call that a monomial, right? Mono for one. If we have 2 terms, we would call that a binomial, bi for 2. If we have 3 terms, call that a trinomial, tri for 3. And if we have something with 4 terms, you know what we'd call that? We'd call that a polynomial with 4 terms. So the end of the naming ends at 3 terms, right? So 4 terms, well, polynomial with 4 terms. So what we have to remember is that all of these are polynomials, right? This is a polynomial with 1 term, it's a monomial. A polynomial with 2 terms is also called a binomial. A polynomial with 3 terms has another name, we call it a trinomial. A polynomial with 4 terms has, well, we call that a polynomial with 4 terms. So a polynomial with 10 terms, we call a polynomial with 10 terms. So we have to make sure we are familiar with the prefixes, and then we can accurately name our polynomials. But anyway, that's kind of the note on the vocabulary. So make sure you know your vocabulary. Right? So we have the degree of a polynomial is the highest exponent there. And the name of the polynomial depends on the number of terms. But what is a term? A piece of math separated by a plus or minus has its own unit of measurement. And units of measurement can be different, and know that we can only add like terms. We can only combine things that have the same units of measurement. Okay? With that, we're ready to crank out this list of polynomials. Okay, so we start with number 1. We have this thing. It's negative 8x to the 7th, y to the 5th. But there's another way of reading it, right? We can read it by units of measurement. We can say that there's negative 8 of these. Right? What are these? Well, these are x to the 7th, y to the 5th. And there's negative 8 of them. So this is only actually 1 term. But since we're talking about the degree as well, the highest exponent is 7. This is a 7th degree monomial. It's only 1 term. It's only negative 8 of those things, right? Of those x to the 7th, y to the 5th. But then we look at number 2. What's happening here? We're trying to add 2 different units of measurement. We have x to the 7ths trying to be added to y to the 5th. It's like we're trying to add apples and bananas, and we can't do that. So we're adding 2 separate things that are 2 separate terms. So this is a 7th degree binomial. Right? So now we have a polynomial with 2 different terms. Remember, separated by a plus or minus. That's what's happening here. So now number 3, this is where things get tricky. What's going on? Right? Well, we have this thing minus this thing. And then when we read it out loud, 7 minus x. Well, when we read it out loud, we just said minus, didn't we? And remember that note that I tried giving, right? If we just said minus, the note that I tried giving was, well, it's separated by a plus or minus. So we just said minus, we know we're dealing with 2 different terms, right? We said 7 minus x. So we know we're dealing with 2 different terms. But if I look at this number 7, what's the unit of measurement? This is 7 what? 7 ones, right? So 7 ones minus x, 2 different terms. But what's the degree? The exponent for x is actually to the 1st degree, x to the 1st power. So it's a 1st degree. So it's a 1st degree binomial. That's how that works. Isn't that cool? I hope you think so. So number 4 would then obviously be a 1st degree. What, right? What are we saying? Let's read it out loud. Negative 7x. Did we say plus or minus? No. So it is a monomial, right? If I know how to spell monomial, that'd be great. Monomial. And then number 5, right? So did we read it out loud? What's going on? We're trying to combine 2 different units of measurement. We have x to the 5ths and x to the 4ths. And remember, like we said before, we couldn't add 2 different dimensions, right? We couldn't add those 2 different dimensions. It doesn't make any sense. So if we can't add 2 dimensions, we can't add these. That's 2 different numbers separated by a plus or minus. So this is then a 5th degree binomial. Now, here's where stuff gets fun, right? So you look at number 6, excuse me, and you're thinking, well, it's a 3rd degree something. True. This is a 3rd degree. At the highest exponent is 3, so that's 3rd degree, right? But is it a binomial or is it a monomial? Whoa. So you may think there's 2, right? But if we had 3 apples minus 2 apples, aren't we still working in 1 unit of measurement? It's 1 apple. So we're still working with 1 unit of measurement. So this is a 3rd degree monomial. Can you believe it? We're working with 1 unit of measurement. So it is a monomial, believe it or not. So it means if you can simplify it, do it. So it is a 1 unit of measurement. That is a 3rd degree monomial. So now we look at number 7. What's the highest exponent is 2. This is a second degree something. All right, so what are our units of measurement? We have x squared y's. We have xy squareds. Not the same. Right? These are not the same. And then, of course, x, totally not the same. So they're each different units of measurement. There's 1, 2, 3 different terms. So this is a trinomial. All right, so now you can see what's happening. And now we have the last two. This is where stuff gets tricky. So what's going on? There's too many x's and y's in numbers. Let's look at the units of measurement first. Always look at units of measurement. We have x squared y's, xy squareds, x squared y's again, and xy squareds again. So check this out. We have 2 x squared y's, and we have 2 xy squareds. So we're only dealing with 2 units of measurement. Now, first of all, we know that the highest exponent is 2. So it is a second degree. But once we combine these like terms, we're going to have a binomial on our hands because there's only going to be 2 units of measurement. So this is actually a binomial, right? So it is a second degree binomial. And then lastly, number 9, a third degree. Well, what? All 3 of these are different units of measurement. And if they're all different units of measurement, that's what we're going to end up with. Polynomial with 4 terms. And that is how we name polynomials. And that's it for today. So I'm starting basic, and that's how it works, and the bell might ring, so let me get out of your way. So that's it, right? That's how we find the degree and the name. Take care.